Hello and welcome to my video where we're going to begin exploring polynomials and some definitions. So first of all, what is a scatter plot or scatter chart? This is where you have a graph, but you just have a whole bunch of dots, and you can follow the dots with the curve. But usually, like if we're graphing something, even with a graphing calculator or with Excel or with Google Sheets, we're using a scatter plot for mathematical functions because you can use those points and you can basically make an infinite number of those points, and if you make enough points it starts to turn into a line. So that's basically what's happening here. Okay, so that is a scatter plot. So polynomial function, what is that? Well, poly means multiple and nomial meaning numbers or terms. And so basically, what are we looking at? We're looking at a function with multiple terms. Basically anything with x and y. It has to have both. Oops. Okay, what is the degree? Well, the degree is the highest exponent on a variable. So usually it's x, so it's x to the 1, x to the 2, x to the 3, x to the 4, etc. The leading coefficient is the number in front of the highest degree. The constant term has no x, just the number. End behavior is based off the leading coefficient, and this is based off the sign, positive or negative sign of the leading coefficient. And so we have a positive will give us a happy or an upwards direction at the end. Okay, we don't really care what happens before that, but it does give us a happy at the beginning or at the very end. And negative means that we're going to have a sad face. Again, we don't care what happens before that, but at the end it will be sad. Okay, a turning point is the basically any time that a graph goes from a positive slope to a negative slope. This here up top is a turning point. Change in slope sign, I guess. And the x-intercepts, if we look at a graph again, it's where the graph, the function hits the x-axis. So here and here, for example, would be x-intercepts. And so not all graphs have them, but they can have up to as many x-intercepts as there are as the degree. Okay, let's take a look at a couple examples here and see if we can do anything with them. So first of all, we have a constant of y equals 2. So what would we do here? If it's a constant, apparently this counts as a polynomial even though there is no x, which is kind of funny, and there's only one term, but it still counts. So anyways, here we have y equals 2, so you can kind of imagine that wherever y equals 2, every single point along that line is going to be on our graph. The next function is also pretty straightforward. We'll take a look at that in a second. So the next one is a linear equation, and hopefully you remember from previous that, like, you know, y equals mx plus b. So that plus b, that's the plus 1 there, that will end up being up here. And then over here is our m, so that's our slope. So in this case, it is positive. So that means that we're going to be going up 2 to the right by 1, up 2 to the right by 1, like this. So in this sort of direction, right? And so now what we're going to do is we're looking at quadratic options. So this is the most simple quadratic, where it goes up like this, and there's only one turning point. Okay, and a cubic, the most simple cubic, starts up here. No, wrong direction. Starts down here, goes up, so it turns twice. So it has one turning point like that, one turning point like this. All right. So compare the number of x-intercepts to the degree or not to the number of turning points. So depending on the graph that you have, you can see different things. But let's just take a look at some graphs here. So look at the leading coefficient and sign compared to the end behavior. So let's just take a look at some options here together and see what happens. So let's do y. Oh, let's change that. So y equals x squared plus 2x minus 1. Let's try that one out. We'll also do y equals x cubed minus 2x squared plus 3x plus 7. No, minus 7. And then we'll do one more. Y equals negative x plus 4. Okay, so there's these different graphs. Let's just make them into mathy looking things. Okay, and we're going to do the first one in blue, we'll do the second one in red, and we'll do the last one in pink/purple. Okay, so we're going to compare the x-intercepts with the degree. Oh, come on, I did it again. There you go. With the degree. So let's take a look here at some options. So we have our first one is alpha x squared plus 2 alpha x minus 1. Okay, our second one is going to be in red. So if you guys aren't sure what I'm doing here, you can definitely take a look at the next video, which I'm going to go through and explain this a little bit more in depth. But here I just wanted to show you guys some of these functions pretty quickly here. Minus 7. And the last one is negative x plus 4. Okay, so we're going to see these ones here now if we press graph. Maybe we want to zoom our negative value a little bit bigger. So let's make this a negative 20. And then let's graph it. Let's see if that works. There you go. Yeah, now we can see the red line a little bit better. Okay, so hopefully you can see here that the number of x-intercepts for our linear equation has only one x-intercept. Our quadratic has 2 x-intercepts. I think I made this one a little bit too complicated. Maybe I can make it less complicated for a cubic function, but you could potentially even have, you could have a simple one. So let's see if I can make it simple. I don't know if this is going to do it right away, but let's see. Yeah, it doesn't quite reach. Okay, you can only see one, but other cubic functions will often also show up like this, and so you'd see 1, 2, 3. 3 different x-intercepts. And again, the point is here that with depending on the degree, you have that many turns. So 1, 2, 3 turns, this would tell us if there's 3 turns, that means that there is it's a degree 4. Okay. So again, if you compare the number of x-intercepts, they can get up to, but they can't surpass the degree. So up to degree. Okay. Turning points can also be up to the degree. Okay. They can never pass the degree. Up to, up to -1 of the degree. Okay. And leading coefficients always tell us the end behavior. So if you look back at our graphs here, you can see that our first one here in blue goes up to the right because it's got a positive value. You can see that our red one here goes up to the right because it has a positive value. And you can see our black one goes down to the right because it has a negative value. So I hope that this video helps you understand some of these definitions a little bit more. And I hope that this video helped. Good luck.